Friends, in this video we are discussing application of the beta function, right? You see, now we have to prove beta of m comma 1 by 2 is equal to 2 to the power of 2m minus 1 times of beta of m comma n. So to prove this one, we have to find out the first LHS part as well as RHS part. If LHS part you are getting some constant or some value, then RHS also should be, you have to get same value. Then you can say in this case these two should be equivalent, right? Now here you observe what is the definition. These are beta function only, na? Both are beta function only, na? Now you read in the definition of beta function. We have beta of m comma n is equal to 2 times of integral 0 to pi by 2 sine to the power of 2m minus 1 cos to the power of 2n minus 1 theta d theta. How it is came means, generally we have a function beta of m comma n in a Cartesian from integral 0 to 1 x to the power of n minus 1 into 1 minus x whole to the power of n minus 1 dx, where this is m minus 1, m greater than 0 and n greater than 0. In this case, the integrand will be, this integral will be convergent. So if you put x is equal to sine square theta and y is equal to cos square theta, right? Then you will have a beta of m comma n and this sine and cosine terms, that is the trigonometric functions, 2 times of integral 0 to pi by 2 sine to the power of 2m minus 1 theta cos to the power of 2m minus 1 theta d theta. Okay, is it clear for everyone? Right. Now what you required actually, beta of m comma 1 by 2 you required. So in place of n, what I have? 1 by 2. So put n is equal to 1 by 2 in this case. Then you will have 2 times of integral 0 to pi by 2 sine to the power of 2m minus 1 theta is common. But in this case you have to put n is equal to 1 by 2 na? Then 2 times of 1 by 2 is nothing but 1. 1 minus 1 is 0. Now cos to the power of 0 theta d theta. What is cos power 0? Non-zero power 0 is 1 or not? Yes. So you will have 1 into this sine to the power of 2n minus 1 theta. Then you will have the same term. It remains 2 to the power 2 times of integral 0 to pi by 2 sine to the power of 2m minus 1 theta to m minus 1 theta d theta. We will have 2 times of integral 0 to pi by 2 sine to the power of 2m minus 1 theta d theta. So you keep this as consider this as equation number 2, and the definition of beta you consider as equation number 1. Now LHS part is up to this is enough. Now go for the RHS part. RHS part we have beta of m comma n and that too product of 2 to the power of 2m minus 1. Okay, let it be. Now we need to find out the beta of m comma n. Okay, same definition. We have a beta of m comma n is equal to this one. If you require another definition also we will use. But to solve this problem, this trigonometric function only enough. So here in place of n you substitute m. Then you will have beta of m comma m. That is 2 times of integral 0 to pi by 2 sine to the power of 2m minus 1 theta cos to the power of 2n minus 1 theta d theta. Okay, you see friends, now I have written the term as here. Now here this is, if you consider both x power 2m minus 1, y power 2m minus 1, you can write x y power 2m minus 1 or not? Yes. So both should be having same powers. So you can write the product of these two. That is nothing but sine theta into cos theta power 2m minus 1. Friends, we have a formula sine 2a is equal to 2 sine a cos a. So sine 2a is equal to 2 sine a cos a we have na? From this what you can write, sine a into cos a you can write as a sine 2a by 2. Is it or not? So this is I am writing. This is in terms of theta. So sine 2 theta by 2. Limits from here, this is as it is. Power you have 2m minus 1. Power you have 2m minus 1. Common power na? That is why 2m minus 1. Now 2, this is a rational function. So a by b. This is a constant. So we no need to do anything here. So take outside. It comes outside. Then you will have 1 by 2 power 2m minus 1. 1 by 2 to the power of 2m minus 1. Already here you have a product of first 2 you have. So in the numerator 2. So here this 2 and this one getting cancelled is nothing but, in this case you have 1 by 2 to the power of 2m minus 2. Because the numerator 2 you have. So it is if it is comes to the downside, then in the denominator you can get 2 power minus 1. Nothing but here this is 2 to the power of 2m minus 1 is minus 2. So outside I have written here. Now integral 0 to pi by 2 sine to the power sine 2 theta power 2m minus 1 d theta. Now to simplify this, what I am doing, you see, let us consider change of the variables we are doing. In this case, consider sin just 2 theta is equal to pi. 2 theta is equal to pi. Friends, consider 2 theta is equal to pi, because here you have in a second one LHS part sin to the power of 2m minus 1 theta, not 2 theta. That is why we are changing here. So 2 theta is equal to pi. Nothing but if you are changing theta into pi, then d theta and the limits also you have to change into pi or not. So differentiate this one with respect, differentiate on both sides. Then you will have 2 into d theta is equal to d pi. Now I have to change the limits of theta to pi. So theta limits I have to write here, lower limit 0, upper limit pi by 2. Now put theta is equal to 0, then pi will be 0. Put theta is equal to pi. Theta equal pi by 2, sorry, theta is equal to pi by 2, that is in upper limit of theta. So that is the upper limit of theta. So pi by 2 if you written, 2 to getting cancelled. 2 times of pi by 2 is nothing but what you will have, pi. So the upper limit of pi is here, upper limit of phi is here, pi. So 1 by 2 to the power of 2m minus 1 2 times of integral 0 to, here you have pi sin phi to the power of 2m minus 1 into, what is the d theta here you have, d theta is equal to 1 by 2 times of d phi na? So 1 by 2 times of d phi, right? Is it clear for everyone? Now this 2 also you take outside, then it will be, you see, 1 by 2 power m minus 2, outside 2 is there, so 2 power 1 plus 1, then you will have minus 2 plus 1 is nothing but minus 1. Okay, now this integral 0 to pi, it is the power 2m minus 1 is there, so this is, you can also write as 2 times of integral 0 to pi by 2 sin to the power of 2m minus 1 pi d theta. So again you have a 2 in this case. So if it is required, then you simplify, but if it is not required, keep it like this only, sorry. So friends, you observe this bracket. Actually this is a value of beta of m comma m. Now you observe this bracket. This is integral 0 to pi by 2 sin to the power of 2m minus 1 pi d pi is nothing but like 2 times of integral 0 to pi by 2 sin to the power of 2m minus 1 theta d theta. Same or not? Because integral a to b f of theta you can also write as integral a to b f of phi d phi. Okay. When you can write this one means, in only definite integral you can write integral a to b f of x dx is equal to integral a to b f of y dy form you can write. So from the equation number 2 you can write this value is beta of m comma 1 by 2. Beta of m comma 1 by 2. So beta of m comma m is equal to 1 by 2 to the power of 2m minus 1 into beta of m comma 1 by 2 to the power of m minus 1 is equal into beta of m comma 1 by 2. Hence this, take this side left side, then you will have 2 to the power of 2m minus 1 in the numerator, then 2 to the power of m minus 1 beta of m comma m is equal to beta of m comma 1 by 2. So you see, beta 2 to the power of m minus 1 beta of m comma m is equal to, we have to prove beta of m comma 1 by 2 or not. So is it clear for everyone? So how to solve this one? Here what we have done, I will repeat again. See friends, first to solve this problem, means to prove this one, we have to consider beta of m comma m in trigonometric function. Okay na? Beta of m comma m in trigonometric function. Later what we will do means, first put n is equal to 1 by 2. You will get LHS part. That is beta of m comma 1 by 2 you will get. Okay na? Next put n is equal to m. Then you will have beta of m comma m. That is in terms of sin 2 theta. Now this 2 theta you change in terms of phi, one variable. Then these two will be equivalent. From this you will get the solution. Is it clear or not? Yes. Thank you for watching this video.